we're going to look at the relationship between position of the parabola and the discriminant, and also the roots of the equation. So we begin, I'm going to use a variable k, and the function that we're going to be working with is here, x squared plus kx plus k plus 3. Now, remembering that we're looking for the discriminant to give us some information about the roots to begin with, b squared is k. So whatever k value has becomes b squared, minus 4 times a, the coefficient of x squared is 1, and c, don't forget the c value is the constant, which is the k plus 3. It's not k plus, sorry, it's not kx plus k, it's this thing, these things without the x. So they're our constant. At the moment we have a parabola which is going through the point 3, and I'll just zoom in a little bit, there it is. Okay, and over here on the left hand side of the screen is the function as this thing varies. I can move this around in a minute. What we can see, it's positive definite. So first of all, we know it's positive definite because, so I'm going to zoom out again and get my equations back and move them down. But we can see it's positive definite because it's above the curve, it's positive, and it's positive definite because we've got a 1. So this thing is always going to be a positive parabola. It's not going to change, but it's not always going to be definite. It's not always going to be above here. What we know is the roots of this thing, where the equation is x squared plus 3. X squared plus 3. So our discriminant value then is b squared, which is 0, minus 4ac gives me an answer of negative 12, and negative 12 gives me no roots. Okay, now some of the questions ask you to find the values of k that, let's say, give positive definite answers. Now you can see that when k is 0 it's positive definite, but as this changes, so too that you can see a number of these values here keep the curve positive definite. In fact, there's a couple of values that give this value here, which is not positive definite because it has a point of intersection. And if I move back here, there's another point of intersection. So when k equals 2, negative 2, the discriminant will actually be 0. But for all these other values, all these values of k in between these two, 6 and negative 2, I have positive definite. And if I look at my discriminant, whenever I'm in between these two values, the discriminant will add up to, well, will give a negative answer. If I'm asked for if I'm asked for equal roots, well, here's one value when the discriminant gives me equal roots. The point here is negative 3. Have a look at the equation again on the top left hand corner. B squared is 36 now, minus 4 times 1 times 4 times 9 is 36. So we have 36 minus 36, 0. The discriminant is equal to 0. And so we get this exact point here. And of course, this is the perfect square, x plus 3 all squared. It's displayed like this in this application because I've entered the I've entered the equation with respect to k. Now, once we go past 6 though, okay, we get now two different, and in this case irrational roots. If I go up past negative 2, I get rational roots here, but they're different roots, they're separate. So the idea being that, as k varies. Now notice, when we talk about finding k is just something that's being multiplied in this whole thing. It's not x. Varying k gives me a different set of x coordinates. So I've got no roots, but when k has different values, it gives me a different resulting parabola. Okay, so just recapping, here's our function for us to find the values of k, which gives us positive definite, negative definite, well, not negative definite in this case. we go to the discriminant. The discriminant is inside the square root sign of the quadratic. So when it's negative, we can't find an answer for x. When it's 0, we find one answer for x, such as 6. And when we find it being greater than 0, such as here or over here, okay, we get two different, well, sometimes rational, sometimes irrational roots. And that's how we find k with respect to the discriminant and also the function.